Okay, so we were on question 1 from the amusement park physics sheet. We had finished 1A and B, and we were on C, where the car speed now changed to 30 meters per second. So we have mv squared over r minus mg, so 50 kilograms times 30 meters per second squared over 80 meters minus, we already figured out this was 490.5 newtons. It hasn't changed. 30 squared is 900 times 50 divided by 80. This first term, did I screw up? Oh, no, I didn't, but then I cleared it. So 900 times 5 divided by 8. This first term should be 562.5 newtons minus 490.5 newtons. So this time you get an Fn that's going to be positive, 72 newtons. What does the positive mean? It means it's going towards the center of the circle, okay, towards center or down, okay? How can that be? Well, if you're going over this loop fast enough, it means that gravity isn't big enough to hold you in the circle. You need something else to help you, and that's why you have a bar over your lap, right? And so this is the case where, like, if the bar wasn't there, you'd go off tangent to the circle. So what's holding you in? It's the seat belt or the bar that's holding you in. Right? It's pushing you down with a force of 72 newtons to add to your weight to keep you in the circle. Okay, and then the last question on number 1 says, at what speed will the passenger be weightless? So we go back to, so the sum of the forces again equal to mv squared over r. And so there's an Fg, and I'll say plus Fn, but we know it could also be minus. Weightless will mean that there's no Fn, that it's 0. So that somewhere in between 20 meters per second and 30 meters per second, there's that magical moment where your butt just lifts off the seat. And when that happens, then mg will be equal to mv squared over r. The m's will cancel. V squared will be equal to g times r. So 9.81 meters per second squared times 80 meters. And then don't forget to take the square root. And what do you get? Is it something like 28.014 meters per second? Okay, that's when you'll be weightless. When the seat isn't pushing up on you and the bar or the seat belt isn't holding you in. All right, number 2 is a Ferris wheel. A Ferris wheel of radius 9 meters is set so that the passengers move at a speed of 3 meters per second. Whew, it's a scary Ferris wheel. 3 meters per second is a lot. If you're sitting on a scale, it would register your weight as the force the seat exerts on your bottom at any given moment. You have a mass of 60 kilograms. What would the scale read when the Ferris wheel is at the bottom? So when it's down here and you're sitting on it, gravity will be acting down, and the seat or the scale, the normal, will be acting up. And so it wants to know, what is this normal force? So sum of the forces will equal mv squared over r. And this time it's Fn minus Fg because gravity's going down, equal to mv squared over r. So Fn should be equal to mv squared over r plus mg. So Fn should be equal to 60 kilograms times 3 meters per second squared over 9 meters plus 60 kilograms times 9.81 meters per second squared. So the first term is going to be 60 newtons because 9 over 9 divides out, so 60 newtons. And the second term, what is that, 588.6? Yeah, 88.6 newtons, and so when you add these together, you get 648.6 newtons. So at the bottom, the scale would read 648.6 newtons. Now the next one is, what about at the top? So at the top, Fg is acting down, and the scale is acting up. Ferris wheel's not going so fast that your butt's going to come off the seat, I don't think. So sum of the forces will equal mv squared over r. This time it'll be Fg minus Fn is equal to mv squared over r. So taking the Fn over, bringing the mv squared over r over, it should be mg minus mv squared over r. Okay, we found these two terms already. Fg was 588.6 newtons, and mv squared over r was 60 newtons. So when you subtract them, this time the scale is going to read 528.6 newtons. So at the top, it's going to read less because gravity's helping you out. So the seat doesn't down here, the seat needs to push with enough force to keep you in the circle plus to balance out gravity. But at the top, gravity's helping push towards the center of the circle, so the seat doesn't have to work so hard. All right, I also asked you to do number 3. And number 3 is 100 kilogram mass is on a typhoon ride. A man, is on a typhoon ride. It is also a mass, I guess. So the typhoon ride is the cylinder where you go in and you stand against the wall and they begin to spin it. And after they get it going to a certain speed, they drop the floor down. Okay, what are the forces acting on this guy? There'll be an Fg. You stay on the wall, by the way, when they do that. Fg is acting down. Friction is acting up. The normal force is acting towards the center. The normal force this time is the centripetal force. So in this question, it tells us the mass is 100 kilograms. The radius is 2.4 meters. Realizes he's moving with a speed of 6.3 meters per second. What must the force of friction be to keep him from slipping? Friction's in the y direction. So sum of the forces in the y keep him from slipping means my is 0. So friction is going up, gravity is going down, equal to 0. So friction must be equal to mg, 100 kilograms times 9.81, 981 newtons, part A. Part B, what is the centripetal acceleration at this speed? And so we know acceleration or force? Force. We know Fc is equal to mv squared over r. So Fc is equal to 100 kilograms times 6.3 meters per second squared divided by 2.4 meters. And when you do this, you should get a force of 1653.75 newtons, part B. Part C says, and by the way, that is our normal force. Part C says, what is the minimum coefficient of friction between the man's back and the wall if he just misses slipping? So if he's just about to slip. And so you're going to do friction is equal to mu Fn. So mu is equal to friction divided by Fn. So 981 newtons divided by 1653.75 newtons. And you should get a mu of 0.593. And it says to be safe, should this be bigger or smaller? Go bigger. All right. You can now do question number 4. It should not be too tough. It's actually almost identical to this. Okay. And then look at back at the sheet because I'll tell you what else to do.